A boat takes 2 hours to travel downstream a river from port A to port B and 3 hours to return to port A. Oopsie. So A to B, this is downstream, this is 2 hours, coming up is 3 hours. Right, so another boat takes a total of 6 hours to travel from port B to port A and return to port B. The speeds of the boats in the river are constant and the time in hours taken by the slower boat to travel from port A to port B is nice. 2 hours, 3 hours. Time taken is 2 hours to 3 hours. Speed ratio should be the other way around. So downstream speed to upstream speed. Sorry. Speed downstream is to speed upstream is 3:2. I can imagine 3:2 as 6:4. Then I can think of this as 5 plus 1 is to 5 minus 1. Or where am I heading with all of this? We know downstream speed is boat speed plus stream speed. Upstream speed is boat stream minus stream speed. So B plus S is 6, B minus S is 4, or boat stream is 5, speed is 5, stream speed is 1. I'm not saying they're 5 and 1, ratio of 5:1. Right? So I'm going to say speed of boat 1 is 5k, speed of stream is k. So 5k plus k is 6k, 5k minus k is 4k, ratio is 6:4, 3:2, time taken should be in the ratio 2:3. Right? The distance between these two is where d, then we are told d by 5k plus k, d by 5k minus k. These are the times taken. This is 2 hours, this is 3 hours. 5k minus k, I have written 5k minus 5. Okay. So 6k, d by 6k is 2 hours, or d is equal to 12k. 12k by 6k is 2 hours, 12k by 4k is 3 hours. And so now we've got speed of boat 1 to be 5k, stream to be k, distance to be 12k. Right. So far so good. So that it nicely works to be 2 hours, and this is in kilometers per hour, that is in kilometers, everything works out, the units cancel out, all of that. What do we need to find? We need to find speed of boat 2. Not just that, we need to find the time taken in hours taken by the slower boat, which is boat 2, because boat 2 takes a total of 6 hours to travel from A to B, to travel downstream. So what have we got to do? We've got to say d by boat 2 plus stream plus d by boat 2 minus stream is equal to 6. And then solve for boat 2, and then the answer is time taken to go downstream, or the shorter time. This one is our answer. And so let's fill this in. 12k by b2 plus k plus 12k by b2 minus k is equal to 6. And then find b2 in terms of k and then simplify and solve. So there are two variables in this equation, but it's actually, technically speaking, only one ratio, which is k, divide by k throughout. 12 by b2 by k plus 1 plus 12 by b2 by k minus 1 is equal to 6. Let's say b2 by k, we call it as x. 12 by x plus 1 plus 12 by x minus 1 is equal to 6. This is 2, I'm going to call it 1 by 2. So x minus 1 plus x plus 1 by x square minus 1 equal to 1 by 2. 2x, 4x, so 4x equals x square minus 1. X square minus 4x minus 1 equal to 0. X square minus 4x plus 4 is equal to 5. We solve this, we can get x. So x square minus 4x plus 4 equal to 5, or x minus 2 the whole square is 5. X minus 2 is plus or minus root 5. X is 2 plus or minus root 5. It cannot be 2 minus root 5. It will become negative. We're talking about a nice ratio. It will be 2 plus root 5. Oops, I erased that. x is 2 plus root 5. Now we come back to this. The time taken here, this is 12 by x minus 1. This is 12 by x plus 1. We're talking about time taken to go downstream. Slower boat to travel from A to B. It should be the shorter time. It should be this 12 by x plus 1. I'm going to substitute that. We're going to talk about 12 by 2 plus root 5 plus 1. 12 by 3 plus root 5. Okay, so 12 by 3 plus root 5, 12 into 3 minus root 5 by 3 plus root 5 into 3 minus root 5. 3 plus root 5 into 3 minus root 5 is 9 minus 5, 4. 12 by 4 is 3. 3 times 3 minus root 5 is the answer. Looks like a speed time distance question with some upstream downstream thing, but it's anything but. It's a deep rooted quadratic equations question. We need to be very careful about every ratio, simplification, all of that. And once again, really tough question. Moody takes 30 seconds to finish riding an escalator if he walks on it on his normal speed in the same direction. He takes 20 seconds to finish riding the escalator if he walks at twice his normal speed in the same direction. And so, let's say Moody takes m steps per minute. Escalator takes e steps per minute. So in the first instance, it will take 30 seconds. So 30 m he is doing. Escalator will also be doing this plus 30, that many steps are there. 30 steps per minute I make this as seconds. I don't want to deal with minutes. Very silly thing to take this as minute. I thought it was minute. Let me take this as second. In the second instance, he is traveling at twice his normal speed. He becomes 2m steps per second and he covers it in 20 seconds. Or this should be equal to 40m plus 20e. The escalator is going only for 20 seconds, 20e. He is going only for 20 seconds but traveling at 2m. So 40m plus 20e, that many steps get covered, which is equal to 30m plus 30e. Manipulate this, bring e this side, m that side. 10e equal to 10m, e is equal to m. Escalator's number of steps per second is equal to Moody's number of steps per second. If Moody decides to stand still on the escalator, the time in seconds needed for riding the escalator, total distance is 30m plus 30e. He goes to 0. That means this also has to be done by e. M was equal to e, 60 seconds. We're done. In a race of 3 horses, the first beat the second by 11 meters and the third by 90 meters. The first completes the race. Second loses by 11 meters. The third loses by 90 meters. The second beat the third by 80 meters. Wonderful. The second beat the third by 80 meters. So the first A, B, C. Now this difference 79 meters. But the second beat the third by 80 meters. What does that mean? That means by the time the second finishes the race, he's got 1 more meter gained over the third. So I'm going to think about only this component. This 11 meter, when B travels 11 meters, C travels only 10. Because his lead B to C increases by a meter in the last 11 meters. Right? So when B travels 11, C travels 10. That much we know. The second beat the third by 80 meters. The ratio is 11x is to 10x. X is 80 or 11x should be 880 meters. So it's a race of 880 meters. Just classic ratios, nothing but A, B, C. When A finishes the race, B is 11 meters behind, C is 90 meters behind. Or B has a lead of 79 meters over C. But by the time B finishes, B has a lead of 80 meters. That is, when B finishes this 11 meters, C travels only 10 more. Or when B travels 11, C travels 10. So if B travels 11x, C travels 10x, the difference is x. This is 80 meters, or the race length should be 880 meters. Let's do this one. Interesting question. In a car race, car A beats car B by 45 kilometers, car B beats car C by 50 kilometers, and car A beats car C by 90 kilometers. The distance in kilometers over which the race has been conducted is a very interesting question. Some race. A beats B by 45 and A beats C by 90. And so let's assume the distance is x. When A beats B by 45, that means when A completes the race, B has done only x minus 45. A beats C by 90 kilometers, or when A completes the race, C has done only x minus 90. Right? The interesting thing here, we are told that B beats car C by 50 kilometers. That means when B completes the race. So we can't compare this state. B should have completed the race, or when B finishes the whole thing, C would have done only x minus 50. Very interesting. It becomes a classic ratios question. The first context, when A does x, B does x minus 45, C does x minus 90. When B does x, then C does x minus 50. Fine. Very simple, very, the only thing we need to think about is ratios, nothing more than that. The ratio of distance covered between B to C is always the same. So x minus 45 by x minus 90 is x by x minus 50. Cross multiply, simplify if you're through. Right? So I'm going to do that. X minus 45 by x minus 90. X minus 45 by x minus 90 is equal to x by x minus 50. Cross multiply, we'll have x square minus 95x plus 45 into 50. I don't want to multiply this. This is 45 is equal to x square minus 90x. This goes off. Take this 95 that side. 45 into 50 is 95x minus 90x, which is 5x, or x is 450 kilometers. A lot of these ratio questions just become races questions, just become ratio questions. And the distance traveled by A to distance traveled by B is always the same, no matter what the length of the race is. B to C, always the same. And so just translate to ratio, we're good to go. In a 10-kilometer race, A, B and C each running at uniform speed get gold, silver and bronze medals. If A beats B by 1 kilometer and B beats C by 1 kilometer, that means in this 10-kilometer race, when let's say A, B and C start here, when A finishes, B has done only 9 kilometer. When A does 10, B does only 9. And then a little while later, B finishes. At that time, C is done only 9 kilometer. B beats C by 1 kilometer. Just remember, only one thing we need to remember. A, B, C are not at the 10 kilometer, 9 kilometer, 8 kilometer point. If B beats C by 1 kilometer, this means when B finishes the race, when B is at the end point, then C is at the 9 kilometer point. After this is a plain old-fashioned ratio question. When A does 10, B does 9. When B does 10, C does 9. And then by how many meters does A beat C? That means when A is finishing, how much has C done? When B does 10 kilometers, C does 9. When B does 8 kilometers, C will do 9 into 9 by 10, which is 8.1. When A does 10 kilometers, C does 8.1 kilometers, or C lags behind by 1.9 kilometers. Remember, we need to give the answer in meters. This is 1900 meters. So the answer is 1900. Two circular tracks T1 and T2 of radii 100 meters and 20 meters respectively touch at a point A. Starting from A at the same time, Ram and Rahim are walking on track 1 and track 2 at speeds of 15 and 5 respectively. The number of full rounds that Ram will make before he meets Rahim again for the first time is? Interesting question. So let's talk about T1, T2. This has radii 100 meters, this has radii 20 meters. They respectively touch at point A. Starting from A, at the same time, Ram and Rahim are walking on track T1 and track T2 at speeds 15 and 5. So 15 kilometers per hour and 5 kilometers per hour. Key thing here, we've got to calculate the time taken by Ram to complete a lap, time taken by Rahim to complete a lap, and then we'll have to find the LCM of those two times. That's the idea. Right? Now, this has a radii of 100 meters. We'll have to think about 2 pi into 100. This has a radii of 20. We'll have to think about 2 pi into 20. So, time taken is 2 pi into 100 by 15. Remember, this is in meters, this is in kilometers per hour. I don't care. Right now, I don't care. We'll come to how we will fix it. But right now, I don't care. I don't care about the units. That unit is actually hour by kilometers, whatever that unit is. We don't care. I'm not looking to write it in seconds. Right? This one is 2 pi into 20 by 5. Now, what we are trying to do is if we're going to compare these two. Right? The 2 pi gets knocked off. This is 100 by 15. Let's knock it off. This is 20 by 3. This is 20 by 5. Right? So, or this is to that. Ratio of time taken is 20 by 3 is to 20 by 5. Or 1 by 3 is to 1 by 5 or 5 is to 3. Right? So, if Ram takes some 5 units, Shyam will take 3 units. Call that as units. You don't care. So, Ram will come at 5 units here, at 10 units here, at 15 units here. Shyam will come at 3 units, 6 units, 9 units, 12 units, 15 units. Why am I stopping with 15? If you call this as 5 units and 3 units, after 15 units of time, which involves a pi and a 5 by 18, 18 by 5, whatever else we want to do, whatever ratios we want to do, after 15 units, Ram will be at the starting point. After 15 units, Rahim will be at the starting point. Both of them meet here. That time, Ram would have done 3 rounds, Rahim would have done 5 rounds. And that's when they'll meet at the starting point again. Or the number of full rounds that Ram will make before he meets Rahim again for the first time. Ram takes longer time. He would have done fewer rounds, 3 rounds. In that time, Rahim would have done 5 rounds. We just need to find the ratio of their speeds. Everything else doesn't matter. Mira and Amal walk along a circular track starting from the same point at the same time. They walk in the same direction. Then in 45 minutes, Amal completes exactly 3 more rounds than Mira. If they walk in opposite directions, then they meet for the first time exactly after 3 minutes. I was put off by this a little bit. If they walk in the same direction, then in 45 minutes, Amal completes exactly 3 more rounds than Mira. Whether they walk in the same direction or in opposite direction, in 45 minutes, they can complete only the same number of laps. And so, if they walk in the same direction, I just didn't get that. Right? So, let's take Mira takes m minutes for a lap. Amal takes a minutes for a lap. And so, in 45 minutes, Mira will do 45 by m laps. Amal will do 45 by a or 45 by a laps. Amal completes exactly 3 more rounds than Mira. 45 by m plus 3 equals 45 by a, or 45 by m, 45 by a minus 45 by m is 3. Nice. They walk in opposite direction, then they meet for the first time exactly after t minutes. And so to complete a lap, Mira takes m minutes, Amal will take a minutes. Or the speed which they travel is lap by m, lap by a. The relative speed will be lap by m plus lap by a. So the time taken for 1 round will be lap by m plus lap by a. This is equal to 3, or 1 by m plus 1 by a is 3, or 1 by m plus 1 by a is 1 by 3. After this, solve these two, we can get m and a and then simplify that. This is 45 by a minus 45 by m, or we'll write these two equations down. 45 by a minus 45 by m equals 3. 1 by a plus 1 by m equals 1 by 3. This I'm going to rewrite it as 1 by a minus 1 by m equals 3 by 45, which is 1 by 15. The number of rounds Mira walks in 1 hour is how much? So we want to find m. If I subtract 1 from this, 1 from the other, this from that, then 2 by m equals 1 by 3 minus 1 by 15, which is 5 by 15 minus 1 by 15, which is 4 by 15. Or 1 by m is 2 by 15. Or Mira takes 15 by 2 minutes for a lap. She takes 7.5 minutes for a lap. The number of rounds Mira walks in 1 hour. In 15 minutes, she'll do 2 laps. In 1 hour, she'll do 8 laps. Points A and B start from a point P on a circle at the same time. Let's look at this. A and B from a point P. A moving in clockwise. So A moves clockwise. B moving anti-clockwise. They meet for the first time at 10 a.m. when A has covered 60% of the track. So this will be diametrically opposite. This will be somewhere around 60% of the track. This is the first meeting. They meet at 10 a.m. If A returns to P at 10:12 a.m., then B returns to P at what time? A returns to P at 10:12 a.m. So let's think about A alone. To travel this distance, A has taken 12 minutes. This is 40%. 40% of the distance A travels in 12 minutes. The remaining 60%, A should have taken 18 minutes to travel. 60 by 40 into 12, and just ratios. So A would have taken 18 minutes to travel the first 60%. Okay, wonderful. So this time taken is 18 minutes, or total distance that A takes. Total time A takes is 30 minutes. And both of them, when have they started? They started 18 minutes before 10 o'clock. So the start time here is 18 minutes before 10 o'clock, or 9:42 is when both of them started. They meet at 10 o'clock here, and then A comes back at 10:12. A takes 30 minutes. Now let's think about B. Right? When A travels 60%, B has traveled 40%. And so A travels 60%, B has traveled 40%. Or their speeds are in the ratio 3:2. We will travel that much distance. The distance are in the ratio 3:2. They travel the same amount of time. Speeds are in the ratio 3:2. Or time taken will be in the ratio 2:3. B will take more time than A. And so A takes 30 minutes. How much will B take? The ratio is 2:3, or B should take 45 minutes. 2:3 is 30:45. B should take 45 minutes to travel this distance. B starts at 9:42. 9:42 plus 45 minutes. 18 minutes takes us to 10, and then a further 27 minutes takes us to 10:27. B takes 15 more minutes than A. A reaches at 10:12. B will reach at 10:27. Very interesting question, just ratios, nothing more than that. And so in a lot of these races, circular races, context where two parts are compared, ratios will take you home completely. Just think in terms of ratios. Nothing else is required. Anil, Sunil and Ravi run along a circular path of length 3 kilometers, starting from the same point at the same time and going in the clockwise direction. So Anil, Sunil and Ravi, clockwise, this is 3 kilometers. They run at speeds of 15 kilometers per hour, 10 kilometers per hour and 8 kilometers per hour. So they go at 15, 10, 8. Anil, Sunil, Ravi. The 3 kilometer track. How much distance in kilometer will Ravi have run when Anil and Sunil meet again for the first time at the starting point? So 15 and 10 meet again.
how much would Ravi have run? So we'll have to see when will Anil and Sunil, A and S, I keep getting confused with the names, meet at the starting point for the first time. So how long will it take Anil to reach the starting point and for Sunil to reach the starting point, and then we find the LCM of those two and then come back to Ravi later on. So 3 kilometer track, Anil will finish it in 3 by 15 hours. Sunil will finish it in 3 by 10 hours. 3 by 15 is 60 minutes. This is 12 minutes. 3 by 10, 60 minutes totally. 3 by 10 into 60, 3 into 6, 18 minutes. We need to find the LCM of 12 and 18. So basically Anil will be at the starting point at time 12, 24, 36, 48. Sunil will be at 18, 36, 54, etc. So at the end of 36 minutes, both will be at the starting point for the first time. So how much does Ravi run in 36 minutes? Ravi runs at a speed of 8 kilometers per hour. 8 kilometers per hour into 36 by 60 hours. 36 by 60 is 3 by 5. 8 by 5 is 1.6 into 3 is 4.8 kilometers. Very routine, simple question. Should be knocking this off. I took a lot of time for this when I was in the exam. I think we had some starting trouble.